Hi, I'm Chris, and in this video we're going to be taking a look at a physics problem dealing with impulse. This is a problem I looked at with one of my students the other day. And here, this kind of problem is where two objects are going to collide. In this case, I believe it was a hammer and a nail, where you hit the nail with the hammer and the hammer came to rest after traveling at an initial velocity of 8.3. So our hammer had a mass of 12 kilograms and an initial velocity of 8.3 meters per second. And then the time over which the hammer came to rest was 8 milliseconds, which is equivalent to 0.008 seconds once we do that conversion. Now for impulse, for part A here, your equation for impulse is equal to your change in momentum, which is your change in mass times velocity. Now the easiest way to calculate that is to look at your final minus your initial. And in this case, your final is going to be a final velocity of 0 because it's coming to rest. So your final velocity was 0, which means that part will actually cancel out of your equation. And you'll have basically 0 minus 8.3 would be a negative 8.3 times 12. So your change in momentum would be V final minus V initial times your mass. That's your change in momentum. And here that's 0 minus 8.3 times 12, which will be negative 8.3 times 12. 12 times 8 is 96. 12 times 0.3 would be 3.6, so that'll be negative 99.6 for your value of impulse on this. So numerically we're looking at 99.6, but the negative sign just means that the force is being applied in the opposite direction that the object is initially moving. And it's important that we understand how force relates to impulse, because for part B of this same question we're going to have to deal with finding the average force by using time. And so that's what we'll see here. To find your average force, impulse is equal to your change in momentum. Impulse is also equal to your change in momentum, which is equal to your average force times the amount of time over which that force is applied. So basically for impulse, you're saying that if you apply a force to an object over a longer period of time, you're going to change that momentum more significantly. So here, we're going to plug in our values for our change in momentum, which we found from part A, and we're going to plug in our value for t, which they tell us in the question, and divide. So you're going to end up with 99.6 divided by 0.008 for your average force, and I'll let you go ahead and do the manual calculation on that. If you want to check your answer, please feel free to shoot us an email, contact@sandersontestprep.com, and I can give you the exact decimal result on that. And the negative sign that you have, all that indicates about your force, this is the magnitude of the force, but the negative sign indicates, again, that force, when you put a negative in front of it, negative just means that force is acting in the opposite direction to the motion of the object initially. For more, please feel free to check out our other videos, and thanks for watching.